Hi everyone. Today's topic is exercise 3.5 additional maths. This is the topic at Indices, Surds and Logarithm. This topic is from O levels additional maths paper. Okay, before starting Indices, Surds and Logarithm for exercise 3.5, we should know the laws of logarithm. This is like the backbone of this chapter 3 about the logarithm. Laws of logarithms. This I have already written here. Okay, first of all, I would like to give the review that we have done the power law. The power law is log base x a power is 5. We can write 5 with log x and a. This is power law. The power will become the coefficient. This is very simple. We have done it. Okay. Second law is product law. In product law, what we have to do when log, like suppose log with base x and two numbers are multiplying a into b. So in multiplication, when you have multiply, you have to write the log with both the numbers. So that will become log xa plus log xb. This is called the product law. Then we have question law. That is, we just have the same thing like log x and a divided by b, like here. So when we have division, this is multiplication, we have to add, with division we have to minus. But in exam, what we have actually, that we have to write single log, like this is single log, there are 2 times log. So you have to remember, like I would like to give an example here. Like when you have log x with, like suppose 5 plus log x with, suppose here is 8. So how you can write the single logarithm? Single logarithm is very important to know, because in plus this multiply is becoming plus. So when we have 2 times log with plus, we can write same basis. So we can write log 1 once, and this plus means this 2 will multiply. This you should know. And the same thing when we have minus, this will divide. So this is single logarithm is very important to know. Okay. I'm moving power law, product law, question law. Then we have change of base law. The change of base law is like one of the important topic, and I would like to explain in detail about the change of base law. Okay. In change of base law, here, okay, this topic, I want to do it separately. The change of base law, students have a lot of problem. I have divided this change of base law into some parts. For example, the first change of base law is what? When you have, this is my, like when you require the third base. This is actually not in the book actually. What is third base? This I have made something like to remember how can we use the change of base law. Third base required. Third base means when you have, suppose when you have log a b, I want to convert this ab into different, I mean change of base means your base will be changed, like this a should be changed. I have to change this base. Okay, but requirement is what? I want to I have to change the base, but the third base means the base will not be A, base will not be B. Base is, suppose the third base, suppose the base is x. So in this situation, what you will write? What you can do? You can write first of all log with base x, log with base x, then b upon a. These a and b are not the bases. So this is a way that this is called, when we require the third base, you have to write. Okay. Second formula I have made, interchange of base. Interchange of base, like when the base is a here, I want to make it b, like interchange. So in this situation, okay, log a and b, I want to interchange the base, like interchange b will, I want to make b as a base, not a third base x. So in this situation you will write 1 upon log b and then a. This is 1 upon, this is very important and I have to use it. Okay, so this we have, like I have given the review of the change of base law, product law, power law, and you don't need to forget the key points. Key points are that log base 10 is called LG, okay, log with base E is called LN, and log x is equals to 1, log x1 is equals to 0, and LG10 is also 1 because base 10 is 10, and ln E is also 1. And please don't forget the index form, a power b is equal to c. This is index form. If you want to convert into log form, you will write log with base a, c is equals to b. Okay, this we actually, like sorry, the key points, I hope that you can see the key points. Okay, now yes, okay, moving to the or exercise 3.5. okay, 3.5, the first is what, evaluate the following, convert them into common natural log using change of base law. Okay, I have to copy this question first and these two questions. Okay, I would like to do little fast because in maths I have to do so many things and it takes a lot of time and makes my video long. Part 1. Okay, this evaluate the following, convert them okay, it means convert into common means base 10, natural means base E. It means I have to make this base 5 or base 7, no, the third base. So that's why the first part is log 5 7 will become LG 7 divided by LG 5, or you can even write ln 7 upon ln 5, there is no problem, and use your calculator and both the answer will be same, there is no problem. Log 7 divided by log 5, and you can get the answer 1 point. Both the answer will be same, even you use ln or LG. LG is base 10 because base 10 third base I have made. So 1.20, this 3 1, this is 1.21. This will become LG 11 upon LG 3, and you can do it, there is no problem. And I would like to move F part. This you can write LG 6.7 divided by LG 2.5, and please do it. Here what we can do, A part solution, LG 5 divided by LG 3 multiply by, you can write LG 27 divided by LG 5. LG 5 cancel. LG 27 means you can make it 3 power 3. Okay, so this 3 power 3 you can write LG 3 power 3 divided by LG 3. This 3 will become the power law coefficient, 3 LG 3 divided by LG 3, cancel, and answer is 3. We have done. Part B. I'm solving part B here. Sorry, part B I can solve here. LG 4 divided by LG 5 multiply LG log 2 10. You can write LG 10 divided by LG 2 25 and 10. You can write LG under root 10 divided by LG 25. Now actually what you have to just simplify, like LG 10 is equals to 1, this LG 2 and LG 4. LG 4 you can make 2 square, so I'm writing it LG 2 square and divided by LG 5 multiply by this is 1 and this is LG 2 divided by under 10 means the power is 1 upon 2, so 1 upon 2 LG 10 divided by, you can make it 5 square, so LG 5 square. Now just power law is applied and you can make here, you can make, okay. So finally I will solve this part here. I'm solving here. This I can make this 2 will become the coefficient, 2 log 2 divided by LG 5 multiplied by 1 upon LG 2. This LG 2 cancel. Here is 1 upon 2 and LG 10 is 1 divided by 2 LG 5. After simplification, 2 upon LG 5, this, okay, this divide, when I make it multiply, this 2 LG 5 will become numerator and this 1 upon 2 will be here. LG 5 cancel, this 2 will become again 1 upon 2 will become 2 upon 1 and when you multiply it's becoming 8. That's the answer. Okay, moving to question number, I think so, yes. What are the important questions? Question number 4. Okay. Question number 4 is one of the important, like we have to do 4 and I'm also copying question number 5. Okay, let's see. In question number 4, without using calculator, evaluate. So you can write here log 2 and 2 square. This 2 will become coefficient, 2 log 2 and 2. Log 2 is 1. So our final answer is only 2. We have done it. Okay. This LG 1 upon 10, what you can write? That you can write, there is 2 methods. First method is, I want to explain everything actually. You can write 2 things. LG1, like 1 upon, when you have divide you have to write minus LG1 minus LG10. This is first. LG10 is equals to what? 1. LG1 is equals to 0 and the final answer is minus 1. LG1 is 0. Please, whenever you have 1, like log 2 1 is always 0. Whenever you have 1 here, it is always 0. Okay, second method is what? Second method, you can move this 10 up and minus 1 power law you can apply, minus 1 log LG10. LG10 equals to what? 1 and answer is coming minus 1. There are 2 methods. We have done it. 2 and you can make it 2 cube, 3 will become 3 answer. This 27 you can make 3 cube, 3 here and log 3 is 1, 3 answer and so on. This here is also, you can do it. But okay, this F part is good. This type of questions I always look log 9 under root 3. Okay, first of all, this I can use the change of base law, but without using calculator. This when I make power is 1 upon 3, I can write 1 upon 3, sorry, 1 upon 2, power is under root 1 upon 2 log 9 and 3. Now there is no possibility to move, but How can I make it 9? Can I make it 9? Is possible? Or what you can do, there are a number of methods. You can interchange this. What? Remember I have discussed with you interchange of this interchange 1 upon change of base. Okay. Why I'm doing this actually? Why I'm doing this? Because I cannot make 9 as 3, but I can make I cannot make 3 as 9, but I can make 9 as 3. So I want to make it interchange 1 upon log 3 9. This 3 is 3 square, and then 3 square means 2 will come here. This is 1, and 2 times 2 is 1 upon 4. This is, if you want to check the answer, question number 2 part F, you can check the answer from here. Like I have the answers. Okay, question number 4, answer is, I don't have book, I have this kind. Question number was question number 4 part F. Okay, 4 part F, you can see 4 part F is 1 upon 4, and we have done 1 upon 4. Okay, 1 upon 4. Okay, evaluate the following expression without using calculator. These are the same type of question you have to convert, but I would like to do all bases the same. Okay, single logarithm is very important, like 8 8. The main thing is to write the single logarithm. Question number 5 part A, I will write log 8 once. 2 plus means 2 multiplied by 4 is 8, and log 8 it is equals to 1. This is the way you have to solve it. Single logarithm, this you have to write log 2 minus means 60 upon 15, simplify and get the answer. 15 times 1 and 15 times 4. 4 is what? 2 square, and 4 is 2 square, like I'm solving C part. Log 2 and 4 will become 2 square, so you can write 2 log 2 that's equals to 1, and 2 times 1 is 2. Like I will move to F part. 5 5 5. Okay, this is very important. You have to remove the power, remove the coefficient first. This 2 will become the power of 3. 3 power is 2 minus log 5, 6 power is 2. This plus is multiply, and this will divide, because a single logarithm, if I want to write log base 5, 4 into 3 square is 9, like 4 into 9 divided by 6 square is 36. Like after simplification, 4 times 1 and 4 times, you can simplify. Here is like blur. 4 9 times is 36, and this is 36, cancel out, is coming 1. So when you have log 5 1 is always equals to 0. I have told you, whenever you have, like I have discussed with here, whenever you have here 1 is always 0, whatever the base is. Okay, so we have done it. Moving to once again exercise 3.5. Like in mathematics, whenever I try to make shortest video, not possible all the time. Okay, question number 4 we have done, 5 we have done. I move to question number 6. Okay, in question number 6, this is the main question, and this will help us in exercise 3.6. Okay, moving. Question number 6, single logarithm. the same method I have to use. Log A, I have to remove this coefficient first. Log A, 8 minus this 2 will become the power of 2. Log A, 8, this minus means I have to divide, and 4 squared is 16. 8 upon 16 is 1 upon 2, and that's your answer. Because we are not solving, we are writing in single logarithm. Part D, 2 will become the power, base is 10, x plus 2 power is 2, lg x plus 1 minus lg. Okay, here actually what you have to make the factors. x square plus 3x plus 2, when you make the factors, x square plus x plus 2x and plus 2 common in first two, x plus 1. I think this is actually the lengthy part, plus 2x plus 1. So the final factors are x plus 1 and x plus 2. So what I can write here x plus 1 and x plus 2. Okay, single log, just write lg x plus 2 whole square. Plus means this will multiply, and minus means these factors will be divided. And by this, x plus 2 cancel out with square x plus 1. The final answer is x plus 2. We have done it. Okay. Moving to question number, okay, this part 8, I would like to solve it. Not all the questions, but at least to give the idea this how we can solve question number 8. In question number 8, the value of log a3 is given and log a5 is given. I have to use it. Okay, what I will do, I will not calculate, but I can write it how we can simplify. Log a15, I have to divide this 15 into 3 and 5. This is our target actually. All the question will be divided into 3 and 5. So I can write log a3 multiplied by 5. Can we write? And when you have multiply, you have to write product law, and this is 5, and put the value here, this value here, like these two values, and you can add and get the answer. There is no problem for this. Okay, I would like to, okay, this 0.6 you can write 6 upon 10, and when you write 6 upon 10 you can write 2 times 3, 2 times 5, then 3 and 5. Okay, you can write minus, like log a, I'm doing C part, 0.6 will become 6 upon 10. 6 upon 10 means you can simplify 3 upon 5. When you have 3 upon 5, you can write 3 and minus log a and 5, and minus means use these value, put the and get the answer. I think so we should move to the next part. I did not find any difficulty in this part, I think so. Question number 9 is also same. Okay, this question number 10, normally I have also found this in the school, teachers do not do this question number 10, but this question number 10 I can show you when I will start the past papers of this topic. I will show you this question. Okay, given that LGX is P, two values are given, relations are given to us, and express the following terms of P and Q. Okay, I am moving to the first part, question number 10, part A. LG, I have to apply x plus 2 LGY, because this 2 will become the big coefficient. LGX is P and 2 LGY is Q, and that's your answer. Okay, this situation we have difficult part here, and these two are the difficult parts. I think so you can do it. LG 10 plus LGX minus LGY. this value given, this value given, this is equals to 1, this is equals to 1, and values are given, you can put, you can get the answer. Okay, but I want to move to E part. In this part, check the relation. What's the base here? LG has a base 10. 10 power p is equal to x. 10 power p is equals to x. This is a new relation when we can have the value of x. Same thing here. I can have the value a power 10 power q. 10 power q is equals to y. Like we have two more relations. It means altogether there are 4 relations. This part E, x and y. What is the value of x? X is 10 power p. And what is the value of y? Y is 10 power q. This is same. You can write once and power will be added, and that's your answer. This is like this actually, and you can try this part as this. Okay. Okay, moving this part. Okay, I'm doing 11 part because this will support us in crash exercise 3.6, and I want to do as soon as possible 3.6 and the past papers. Okay. Find y in terms of x. Y is the subject. LG, the same thing we have done in last exercise. What you can do? What's the base here? Okay, this base is 10. LG y is equals to, can you make it LG? How can you make LG? 10 is 1, okay, LG 10, I can write LG 10 because LG 10 is 1. Suppose we have here log 2, here log 2, so I have to write here log 2 2 because log 2 2 is, I want the same basis here, that's why I will write LG plus 3, I can write LG x power is cube. Can you write single log here in right hand side? Okay, single log is 10 multiplied by x power cube. Now do we have the log both the sides? In this situation, when we have log both the sides, what we can do? We can compare only this part. Like we can write this part is equals to this part. So we can write y is equals to 10x cube, and that's your result, and we have done it. This is a way to make y the subject. This is okay, good, but I think so 3.6 will help us to, like 3.6 is most important exercise because all the questions are very important. Okay, thank you so much for watching my video, and please share with your friends.